All right, hi everyone, and welcome back to lesson three. So lesson three involves determining the greatest common factor, which you might maybe remember from middle school. It's okay if you don't. We're just going to do a little refresher. So in order to be successful with determining the greatest common factor and factoring out of a expression, we need to know how to divide polynomials. So, um, similar to multiplying with variables, when you divide, when you multiply, you add the exponents. So when we divide, we do the opposite. We subtract the exponents. So for example, if we have x to the third power and we're dividing it by x to the second power, you simply just subtract the exponents. So that would equal x to the 3 minus 2, which would be x to the first power or just x. Okay, so just as a side note to put in your notes is you subtract the exponents when you divide. Dividing. Okay, so this will come in handy as you move on with this lesson. All right, so number one. So don't get nervous. It looks like a fraction because it is a fraction, but what we are simply doing is we're dividing this binomial on the top, these two terms, 3x squared minus 6x, divided by 3x. So what I like to do to just visually kind of organize my thinking is to write it out just like this. So we have 3x squared. We know we're dividing that by 3x. And we have this negative 6x, which we're also dividing by 3x. So I'm just splitting this up a bit just to kind of organize for you. So here, we're going to divide going from left to right. So we have 3 divided by 3, which we know is 1. Now, x to the second divided by x, remember this has an invisible 1. So that 2 minus 1 just becomes x to the first, which you don't need to put to the first power. And I also don't need this one. So we're just going to leave it as x. Next, we have negative 6 divided by 3, which is negative 2. And now, x divided by x, just as a side note, when we have x divided by itself, this is to the first power and this is to the first power. We know 1 minus 1 is 0. So, and anything to the 0 power is 1. Okay, so therefore, this becomes 1, and we're just left with that minus 2. We don't need to put that times 1 there. Okay, so let's move on to the second one. So now we're taking a trinomial. The 3 terms on the top, and we're dividing each term by 2x. So I'm going to write it out just like I did before. Make sure you include the signs in front of each term. So here we're dealing with all positives, so not that big a deal. All right, so let's go from left to right. So we have 6 divided by 2, which is 3. X to the third divided by x. Remember, this has an invisible 1 to the first, so 3 minus 1 is 2. Next, we have 4 divided by 2, which is 2. And x to the second divided by x to the first. 2 minus 1 is just x to the first, which you don't have to put the 1. Now, we have 2x divided by 2x. When you have the same thing divided by itself, it is just simply 1. Okay? And that would be your answer. Okay, number 3. We have, what is 6y to the 6th minus 18y to the 3rd minus 12y squared divided by negative 3y squared? So this is just written out as a question. So they want you just to divide each of these terms by negative 3y squared. So I'm just going to write it out just like I did with 1 and 2. So you have 6y squared divided by negative 3y squared. Here, the signs are important because you have some negatives involved here. Minus 18y to the third divided by negative 3y squared. And last, we have negative 12y squared divided by negative 3y squared. All right, so let's do our division. So 6 divided by negative 3 is negative 2. I'm sorry, this was y to the 6. Sorry about that. And then we have y to the 6 divided by y squared. So 6 minus 2 is y to the 4th. Now, negative 18 divided by negative 3 is positive 6. Y to the 3rd divided by y squared. So 3 minus 2 would just be y to the 1st. Here we have negative 12 divided by negative 3, which is positive 4. And y squared divided by itself is just 1. And that becomes 1. Oops. That becomes 1. And we can just leave it like this. And this would be our answer. Sorry about my handwriting. I know it's kind of terrible. All right. So today's lesson is about finding the greatest common factor. So what is the biggest number that divides into the following? So when we're finding the biggest number that divides into two numbers, we're finding the factor that they both have in common. So factors, if you want to write, factors are numbers that multiply to that number. Okay, so for example, 2 and 4. The factors of 2 are 1 and 2, and the factors of 4 are 1, 2, and 4. So the greatest number that goes into both 2 and 4 is 2. So your greatest common factor would be 2. Let's look at 10 and 15. So the factors of 10 are 1, 2, 5, and 10. Right? 1 times 10 and 2 times 5 is 10. And the factors of 15 are 1, 3, 5, and 15. So what is the greatest number that goes into both? So if you see, the largest number here is 5. So your GCF is 5. Next, so here we're dealing a little larger numbers, but the same idea. So 25. The factors of 25 are 1, 5, and 25. Okay? And the factors of 75 are, so we have 1, we have 3, 5, 15, 25 goes into it, and of course 75. So 1 times 75, 3 times 25, and 5 times 15. And what is the largest number here? So we can see the GCF would be 25. So I'm just going to write that here. And here we have variables. So how can we find the GCF of x and x squared? Well, x, the only factor of x is 1 and x, right? Because 1 times x gives you x. Now let's see x squared. Well, 1 is a factor of every number. And what is x squared? X squared is x times x. Okay, so what can be factored out of both? What is the greatest common factor? So in this case, the GCF would be x, because x Whatever that number is the largest one that goes into both x and x squared. So your GCF is x. An x could be factored out of this one, and an x can be factored out of x squared because it consists of two x's. Okay. So here I have just the definition of GCF for you and equivalent expressions. So the idea of equivalent expressions is very important. So they're expressions that are the same, but they are basically in different forms. So you're going to see that in this next little piece here. So first, let's do this little exercise together to get you guys thinking. So multiply the following expression using the distributive property. So here we have the 4 in front of the parentheses, so they want us to distribute the 4 to the x into the positive 3. So that becomes 4 times x plus 3. When we distribute it, it becomes 4x plus 12. So these two things are equivalent. They're just in different forms. Okay? So think about it. How can we go back? How can we go from this, from 4x plus 12, to 4 times x plus 3? So hopefully you're thinking it. Well, it has to do with the GCF. If we take 4x plus 12 and let's think, what is the largest number that goes into 4x and 12? So in red, I'm going to put the factors of 4x. So 4x, we have 1 goes into 4, 2, 4, and we have 1x. And let's look at 12. 12, we have 1, 2, 3, 4, 6, and 12, right? So the largest number we can take out is 4. We can't take out an x because the 12 doesn't have an x. So our GCF is 4. So what we're going to do is we're going to factor this. So we're going to divide 4x plus 12 divided by 4. So we're going to take out our 4 by factoring it out. So factoring is really it's basically dividing by the GCF. So you're dividing out the greatest common factor. So you put the greatest common factor on the side, and we have 4 divided by 4 is just 1x, and 12 divided by 4 is 3. So by factoring out the GCF, we get it back to this form. So these two things are equivalent. 4x plus 12 is equal to 4 times x plus 3. So this is our factored form. And this is our expanded form, okay? So we're going to do another exercise to so these are equivalent, but just different formats. Here, it's expanded. Everything's multiplied out. Nothing can happen. Here, it's in factored form. The GCF of this is outside of the parentheses. All right, so we're going to move on, and you'll see if you're a little confused, we're going to do a few more exercises for you to practice. All right,